All right, guys, welcome to Marine Biology, Week 2. I hope you guys all had a great week and are ready to go ahead and get started for today. Welcome, Anne and Paul. Oh, and Paris just joined us. Wonderful. So we are going to talk about fish today. I'm hoping that you guys had a chance to do your homework. I did grade the ones that were turned in last night. However, I did not close the class yet. So if you did not finish the homework, or I did not close the homework assignment. If you did not finish the homework from last week, please be sure and go ahead and do that for me today so that I can finish your grades and close your homework. If you did turn your homework in, there were a few questions on it that needed some additional grading, and I did go ahead and do that. So make sure you go back and look at your grades. All right? I'm glad the three of you are here with me today. We're going to talk about osteichthyes today, which some of you may or may not have been curious and taken a look at what an osteichthyes is. An osteichthyes is a bony fish. But before we get started on that, I want to just quickly review what we went over last week. So last week, we talked about the scientific method and the different zones in the ocean. So I just unlocked your whiteboard. I'm going to make a little chart up here for us. Remember, you may want to make your whiteboard larger when we're drawing on it. In order to make your whiteboard larger, you're going to, it's the bottom right larger rectangle. You're going to click on it. And there's an arrow that looks like it's up and pointing to the right-hand side of your screen. Click on that, and my picture goes away, and the whiteboard comes up. I'm hopefully, locking everyone's erasers so nothing gets erased by mistake. But there were 3 layers of the ocean that we talked about. The euphotic zone, the bathal, and the abyssal. Now the euphotic zone is the top. And the abyssal zone is the bottom layer. I want you to try to think about some of the animals that we talked about and go ahead and put them in the right zone. Or if you can't remember an animal we talked about, you could put a characteristic. Like, for example, I remember that from the abyssal zone, there's no light. So I'm going to go ahead and put that up here. No light gets here. Okay, so go ahead and fill in what type of animals you might find, and there may be some overlap. You may find some animals in more than one layer, which is fine, but go ahead and fill some information in for me. All right, a couple of things on there. Remember to write on the whiteboard. You're going to click the box that looks like the letter A. It says text block when you move your mouse over it. Click on that and then click on your screen. Okay, you guys came up with some great ideas and great animals. Oh, go ahead and finish writing, whoever's writing. I'm going to give you guys 2 more minutes. Okay, it looks like you guys got a lot of the key features here. Some euphotic animals were sea turtles, kelp, sharks, whales, including dolphins, jellyfish, coral, and seaweed. Great job. The light penetrates this area, so animals that need the light can go here. In the bathyl zone, there's viperfish and octopus. Good job. And in the abyssal zone, we have giant squid and anglerfish, and there is no light there. Perfect. So that was a great review from last week, and today we're going to talk about bony fish. A few of them are on this list. Actually, only 2 of the animals on this, 3 of the animals on this list fall into this category. So staying here on your whiteboard, I'm going to get rid of this. And we're going to try to come up with some characteristics of bony fish. What are some characteristics? You guys can either just hit the talk button and talk, and I'll type for you, or you can go ahead and add them up here on the whiteboard, whichever you would prefer. Anyone have any characteristics of bony fish? You can type them up, or you can go ahead and talk, and I will type, and I'll add some up here as well. Okay, remember last week we had talked, or I had told you, that this class is a lot more fun when you guys get involved in it and interact with me. So let's try to come up with some ideas. Some have bones, very good. I put up they live in water. They can be marine or fresh. They have gills. Anyone else have anything? If you're wrong, it's not a big deal at all. We're just trying to come up with some ideas. And if you don't know any, that's okay as well. You can put up some examples. Okay, good job. It looks like we are going to have some great learning from today's class then. I put some examples up here, a sunfish, a sailfish, and a trout. Now, one of these examples we are not going to talk about today. We're not going to talk about freshwater fish in particular. However, they are bony fish, so the characteristics are still the same. So now, if you could make your whiteboard smaller for me. You do that by clicking that same little arrow, except now it's pointing down. And we are going to make our PowerPoint screen larger. To do that, you now should see something that says Asi Ichthys with a skeleton of a fish. On that rectangle, if you could click the up and to the right button for me, your PowerPoint is now larger. Now this is a skeleton of an osteichthyes. Osteichthyes means fish with bony skeleton. Some fish have bony skeletons, and some fish, like sharks, have cartilaginous skeletons. Today, we are only going to focus on fish with bony skeletons. There are more than 20,000 species of bony fish. There are some examples right here. Some of them are a little harder to read. There's a catfish, a carp, a suckerfish, a sunfish, a crappie, a rock bass, a perch, a shepherd, and a silver bass. If you look at them though, they all kind of look the same. Another characteristic that all fish have in common is they move. Well, you may ask why. Why do fish need to move? There's several reasons that they need to move. Would anyone like to read this slide? Any volunteers? Go ahead and just raise your hand if you want to volunteer to read. The little hand icon is right on the bottom. No volunteer readers? All right. So why do fish need to move? Well, they need to move to increase their chance of survival. They move so that they can reproduce. They move to find food and shelter. They move to get oxygen. Some fish move to migrate. And they move to avoid predators. All of these reasons are why fish move. They all do not migrate, but some do. They all do not need to move to avoid predators. Some of them just stay hidden. Some of them don't need to avoid predators. But fish in general, while they are moving, want to use as little energy as possible to get what they need. They do not like to move. Some of them move much nicer than others. What slows a fish down? Well, drag is something that slows a fish down. Drag is also something that slows a race car down. It's also something that slows an airplane down. The ideal fish is streamlined, like the images we saw in the original picture. It's pointed at the front, gets a little bit bigger as you go back, and then tapers down again. This picture here of the diver with the fish that looks like a ball, that is not a streamlined fish. He is using lots of energy to move. The barracuda, whose picture is right here, is a very streamlined fish. Take a second to look at the barracuda. His nose is very pointed. He looks almost like a torpedo. That is a streamlined fish. There are several types of fins on a fish. And each fin has its own name. There are tail fins, which are called caudal fins. If you look at this diagram down here, they are to the right, back on the fish's tail. There are two types of paired fins. There are pectoral fins and pelvic fins. Now, a paired fin means that there is a pair of them. There are two of them on the fish. The pectoral fin is closer to the head of the fish, and the pelvic fin is on the bottom. But there is one each side of the fish. Then there are two medial fins. a dorsal fin, and an anal fin. The dorsal fin is up on the top of the fish, and the anal fin is on the bottom of the fish. Some fish also have a third medial fin called an adipose fin, and that's on the top of the fish close to the tail fin. Go ahead and take a look at this picture of the external anatomy of a fish. Okay, this is probably a sight that is pretty familiar to you. Most people have seen fish and are comfortable looking at and determining the characteristics of a fish. So on here, the fins are again labeled, as well as something called a lateral line. Now the lateral line on a fish we are going to talk about in a minute, but it is there to help them sense vibrations in the water. We also have the scale, which is up on the top left. That's kind of a zoomed in scale for you to look at. The fins are labeled. In the front of the fish, there's one other thing labeled, and that's called the gill cover. And that is what is used to protect the delicate gills of a fish. So that's kind of an external glimpse of our fish. Now we said they need to move, but how on earth do they move? Well, a fish swims by contracting muscles on one side of its body, like a wave, along one side of its body going from head to foot. And then it does the same thing on the other side. So all of the muscles on the right side of the fish work together, and all of the muscles on the left side of the fish work together. If you have ever caught a fish and filleted a fish, you know that the muscular part of the body is on either side. And its organs, its skeleton is all straight up and down the middle. So here's a diagram of how the fish swims. So let's take a look at the long, skinny fish numbered 1 through 5. The fish takes its tail and its whole body and sort of makes an S. That's step 1. In step 2, it begins to move forward, and it's thrusting against the water to one side or the other. In step 3, it's almost in a straight line. In step 4, the tail goes in the other direction. And in step 5, it's beginning to come back towards the bottom of your screen. And in order for a fish to swim, it constantly makes the same movement through the water. On the right-hand side of this image, there's an A, B, and C fish. Those are fish with different body types and what part of their body moves. So fish A is more like a snake-like, maybe an eel-like fish. And the part in blue shows you how much of its body is actually moving as it is swimming. Type B fish would be more like a bluefish or a striped bass. Only the bottom, maybe quarter or third of its body is involved in the movement. And type C would be maybe a puffer fish, where really only the last little bit of that fish that is involved in the movement to make it swim. And the type of tail or the type of caudal fin that a fish has makes a big difference in how it can swim. So go ahead and take a minute and read the captions underneath each of these fins, please. Okay, go ahead and answer the question that I just sent you about types of caudal fins. What would your answer be? Go ahead and use the chart. What type of fin moves very slow? There actually are two correct answers for this one. Just waiting for one more. All right, you guys got the correct answers. The answer could have been either rounded, which is very common in slow-moving fish, or pointed, which is found in slow-moving fish as well. Great job. Okay, let's try another one. Okay, what type of fin is found in high-speed swimmers? There are a couple of different answers you could have here. Now, the shape of their fin, while you guys are thinking, helps them move water differently, which is why different shapes of caudal fins allow a fish to move differently in the water. Okay, and we have crescentic fins, which are found in continuously high-speed swimmers. Awesome. We have emergent and marginate fins, which are found in slow movers, but they are very capable of fast dashes, so that would work here as well. And we have a forked fin, which is found in continuous high-speed swimmers. Great, great job. So the shape of the caudal fin helps the fish swim fast, like a lunate shape, while others make the fish swim slow but turn well. So depending on the type of caudal fin the fish has, depends on how a fish lives and how it gets away from its predators. Fish who rely on speed can live in the open ocean. A fish who is not very fast is going to have a hard time escaping predators in the open ocean. They are going to need to live somewhere like a coral reef, a marsh, somewhere where they can hide. The paired fins on a fish help control the direction a fish moves. It helps the fish turn, it helps the fish slow down. The medial fins, the dorsal and anal fins, help prevent the fish from spinning and keep it stable in the water. They're kind of like the rudder on a boat. If you have a sailboat or have ever been on a sailboat, the rudder of the sailboat keeps it straight up and down, or only allows it to tip a certain distance either way. That is what the medial fins, so the dorsal and the anal fins, do. Typically speaking, the cruising speed, or the speed at which a fish can move, is about 1 or 2 body lengths per second. So if you have a very small fish, it can move 1 or 2 body lengths a second. So if we have a toadfish, who is normally about 11 inches long, it could go between 11 and 22 inches per second. If you had a killifish, which is typically 3 inches long, it could only move 3 to 6 inches per second. Now, some fish can move much quicker for short amount of time, just like some animals can run much faster than other animals for a short amount of time. So let's take a look at this fish right here. This fish right here is probably a fish that you guys have recognized. It is a salmon. I want you to take a look at the fins of this salmon. What type of fin does this salmon have? Anyone remember? If you don't remember, just go ahead and hold on. If you don't remember, I'm going to make a don't remember. All right, what type of caudal fin does this salmon have? If you're not sure, go ahead and hit the question mark one. Awesome. 2 of you got it. It is an emarginate caudal fin. Great job. Now here we have a yellowfin tuna. Now a yellowfin tuna, if you look at it, it's very streamlined. It's very torpedo-like. Even its fins are torpedo-like. If you look at his dorsal fins, they're angled to the back. Looking at this yellow tuna, who would like to make a guess as to how this fish swims? Go ahead and hit your talk button at the bottom of the screen. Who would like to make a guess as to how this yellowfin tuna swims?
I think it's really quickly.
You are exactly correct. The yellowfin tuna swims very quickly. It's very torpedo-shaped, and its back fin, its caudal fin, is meant for pushing water away quickly. Now, the yellowfin tuna lives out in the open ocean and is a very speedy fish. Great job. Now, here we have our barracuda again. We looked at the barracuda earlier in the class. The barracuda is a very torpedo-shaped fish as well. Who would like to make a guess as to how the barracuda moves through the water? Go ahead and just hit your talk button. Go ahead, Paul. Make sure you hit your talk button.
It moves very fast.
Great job, Paul. The barracuda moves very fast as well. It is very torpedo-shaped, it is very elongated, and its caudal fin, this isn't a great picture, but its caudal fin helps push the water out of the way quickly. Now, we have our next fish. This fish is a flounder. Any guesses as to how this fish moves? This one is a great example of the caudal fin. Paul, go ahead. Great. The flounder moves very, very slow. If you look at his caudal fin, it is very rounded. If you look at his whole body in general, he is very rounded. There is nothing torpedo-like about this flounder. Now, if you aren't familiar with flounder, they actually swim on one of their sides along the bottom of the water. So actually right now you are looking at either the right-hand side or the left-hand side of the flounder. He is quite fat, Anne. This picture shows you where the muscles of a fish are. Now, if you look in the man's hand by his knife, he is holding the muscle of the flounder. That is what allows the flounder to move. Now, along with being able to move in the water, a fish need to do a few other things. But while they are moving, one of the main things they are doing is getting prey or getting away from predators. We are going to take a minute and we are going to watch a little video clip about sailfish trying to catch some prey. So you're going to need to listen to the directions to find the video. If you have your PowerPoint screen large, you are going to need to make it smaller by clicking the arrow in the top right that's pointing down. You now should see the screen with my picture, the PowerPoint picture, and the whiteboard. I need to turn my video off so that the video will work better. So I am not there anymore. Now you are going to look at your whiteboard screen where we were writing, and you are going to make that screen larger by clicking the arrow that's pointing up and to the right. Your whiteboard screen should be larger, and I just erased it. Along the top of your whiteboard screen, there are 3 icons. If you click the third icon that says Applications, you should see in black ink something that says Sailfish. Please don't click on it yet. Okay, I'm sending you a poll to make sure we're all at the same spot. Does everybody see where it says Sailfish? Okay, I have 2 answers. If you look at your whiteboard screen where we were drawing, okay, if you look at your whiteboard screen where we were drawing, Paul, right on top of that rectangle, there are 3 icons. One says whiteboard, The second one says presentation, and the third one says applications. Click on applications, and now you should see the word sunfish. Okay, go ahead and answer me in the text chat if you see it now. It says sailfish, I'm sorry. I think I just said sunfish. Go ahead, Paul. Okay, perfect. So now what you guys are going to do is you're going to click on the sailfish word. It's going to take you to a video. When you're done with the video, you're just going to close it, and then you're going to come back to class. Okay, pay attention to what the fish look like in the video and how they are trying to catch their prey. Okay, so what did you guys think of the video? Anyone? Oops. What did you guys think of the video? Anyone want to share their observations that they made about the sailfish with us? Go ahead, Paul. You know what? It was just really hard to hear you, Paul. I'm wondering if maybe your microphone is too close to where you're trying to talk. Maybe move it back a little bit and try again.
I like how they work together.
Perfect. That was much better, easier to hear you. You're right. They did work together. I thought that was pretty neat. I would not have pictured, you know, fish working together. I thought that was pretty cool. Anyone else make any observations besides Paul? Anne, go ahead. Anne, unfortunately, I see you pushing the button, but I don't think your microphone is working. Do you want to go ahead and write it in the text chat for me? Okay, while Anne is writing, I'm going to share with you some of my observations. Their fins and body shape are extremely helpful in the type of environment they are in. Very good. Their bills or their snouts, whatever you want to call it, they used them to sun the fish, which I thought was very interesting. And then when they passed back through, they ate the fish, which I thought was neat. I also thought that it was neat in the video where the bait ball, which is what they call the big group of fish, when it started to go towards the bottom, how they chased it back up to the top. I thought that was interesting. And I did go ahead and put in a text chat, and we'll talk about it more when we talk about whales, but humpback whales do a very similar thing, but instead of using their bills, they use bubbles. And so we'll talk about that in a second. But if you looked, or in a couple of weeks, I'm sorry, if you looked at the sailfish, they are really cool and powerful animals. Pretty much the entire animal is muscle. So now we're going to go ahead and look back at our PowerPoints. So in order to get there, you're going to make this whiteboard screen smaller. Now you can see me again, the 4 larger rectangles. And your screen on the PowerPoint, I just changed to fish senses. You can make it larger if you'd like, or you can leave it small, up to you. I'm going to make mine larger so it's easier to read. Sight. Some fish can see color, and some can see in very dim light. Fish who live in the abyssal zone that we talked about, where there's no natural light, they have huge eyes, and their eyes are adjusted to seeing just light that's given off by other animals. Can anyone remember what we called that? If another animal is giving off light, there's a special word for it. It starts with the letter B. It's called bioluminescence. Hearing, some fish can hear the vibrations. Smell, fish have nostrils used for smelling. Touch, fish can feel objects against their skin. And they have a lateral line, which is a system of canals on the sides of the fish that help detect change in pressure. Now we're going to skip ahead a few slides here and talk about the lateral line of a fish. Here's a cartoon picture of a fish. Now the lateral line is, most of the time you can see the black line of the lateral line going from the fish's head towards its tail. In this picture, the green arrow is pointing at it. In this picture, there's a red arrow pointing at it. On the bottom of this fish, you can see a side view of a lateral line. The bottom being the part that's closest to the middle of the fish. You have the fish muscles with their nerve endings and sensory hairs inside. Then you have the darker blue of the scales of the fish. Going from front to back, they kind of overlap each other a little. Coming down through the scales are these pores or canals. So when someone jumps in the water, when a predator or prey moves in the water, it sends a vibration that the fish feel through these pores and canals. It goes in and it touches their nerve sensories, and the fish can then translate that into something's moving next to me. I either better get away because it could be a predator, or I better go closer because I'm hungry. And here's another picture just of where the lateral line would be on a fish. Fish, quote unquote, hear using their lateral line. It's a line, the technical definition is it's a line of pressure sensors running along each side of a fish that picks up pressure waves or sound in the water. So when somebody pounds on the side of an aquarium, it creates waves of pressure in the water. That to the fish would sound like if you were to cup your hands over your ears and pound on your ears. It is very loud to them, which is why at aquariums and fish stores, there's all the little signs on the tank that says, please don't touch the glass. You're hurting the lateral line of a fish. Now, the lateral line has several functions. It detects the change in pressure and vibrations and currents. It detects the prey. It allows the fish to swim together in a school. They can feel each other. It detects predators on the side or behind them. And it picks up vibrations from the swimming together of other animals. And I think that is where we are going to stop today. We're going to look at gills real quick, but we'll come back to swim bladders. Okay, so how do fish breathe? They use their gills to absorb oxygen from surrounding water. You use your lungs, they use gills. At the bottom here, there's a picture of the gills of the fish. They're little red slats. They're not visible from the outside because they are covered by either a gill cover, or the fancy name for that gill cover is an operculum. There's three main parts of a fish. There's the gill arch, which are structures that support the gill filaments and gill rakers. There are gill rakers, which prevent food from clogging up the gill filaments. And there are gill filaments, which are finger-like projections where oxygen is absorbed and carbon dioxide is removed. So those red things you saw were the gill filaments. And here's a picture of each section. The gill filaments are here. They're almost feathery looking. The gill arch is where it is attached, and the gill rakers are in front of the gill arch to keep the food out. On a fish, this is where they would be located. The gill arch is a bony structure in front of the gill filament. The operculum is a muscle that covers gills to protect them. And then there is water that emerges through the gill slits that allows the oxygen to be filtered out of the water. Now your screen should have just changed, hopefully, to your homework for this week. On your PowerPoint screen, does everybody now see a document, not the PowerPoint? Just a bunch of words. Not, click Documents on that top tab. It should say Presentations, Documents, Desktop. This is your homework for the week. Your homework this week is a little bit more than it was last week, but you shouldn't feel like you have to spend more than about an hour on it. If you would like to, go right ahead. But if you hit the hour mark, you can go ahead and just turn in what you have. Now this is all located in the Moodle site as well, but since it's your first project, I wanted to go over it with you. You are going to choose any bony fish. It has to be a bony fish, so sharks do not count. You are going to create a pamphlet about your fish. In your pamphlet, you are going to have at least 2 pictures. They can be hand-drawn pictures, or they can be pictures you find off the internet. You're going to talk about your fish's habitat. Does it live in the open ocean? Does it live in a coral reef? You are going to talk about common feeding behaviors of your fish. What do they eat? Are they like the sailfish and have a cool way to hunt, or do they just eat a fish or a worm? You're going to tell me 2 key or distinguishing features about your fish. 2 neat things that other fish may not have. So, for example, a sailfish has that bill. They have gills, which would not fall into this category. Something that not all fish have. Some fish have whiskers. That would work here. Some fish have appendages that look like legs. That would work here as well. And 3 other important facts. 3 things about your fish. Your pamphlet can be hand-drawn or typed, up to you. You can either scan it to me if you have a scanner at home. If you don't have a scanner and you just want to take a picture of it and send me the JPEG, that's fine. If you create it on the computer, you can just send me the PDF of it. That's fine. Or a Word document. And your pamphlet can be anything you want. I want you guys to be creative here. If you want it to be just folded in half like a bifold, you can do that. If you want to fold it maybe like you would see a travel agent paper and fold it in 3s, that's fine. If you just want to do it on a normal sheet of paper, that's fine. The important thing is that it's your work. I don't really care what your mom or your dad or your older brother or sister can do. I want to know what you can do. I want to know that Anne's favorite fish is the pufferfish, and she came up with her project herself. I don't want to know that Anne's mom's favorite fish is the pufferfish, and she found all sorts of beautiful pictures and crazy facts and had it done at her graphic designing studio. Okay, I want this to be your work. Okay, does anyone have any questions about either the homework or anything that we did today in class? Okay, so we're going to take the last couple of minutes to review some of the things that we did do in class today. And one of those things is a look at the fins on a fish. Your screen now should have on it a diagram that says parts of a fish. Go ahead and take a look at this fish, and let's figure out what is what on this fish. What is another name for the tail fin of this fish? Anyone? Another name for the tail fin of this fish? Go ahead, Paris.
The caudal fin.
Awesome, great job. On that note, we are going to say goodbye for the week. I always like to end on a high note, so great job. Next week, we are going to share our pamphlets. So be prepared. I will have them uploaded so you guys can share them and talk about them and maybe give us a little background about whatever your favorite fish is. If you have any questions during the week, feel free to give me a call or send me an email. I hope you guys have a great day.